Ryan, Connor, Grace, ready for round number 2? Let's hear it.
It's time for Maths with Mr. Thomas.
Woo! Here we are with Advanced Higher Maths. This is the course. As you can see, it has been split into 14 chapters to take us right across the year. We are starting with chapter 1. This is partial fractions and lesson number 1, distinct linear factors. Before we dive into this lesson though, splash, we're going to look at different terminology that we will come across in the chapter. So different words that we will see and we need to know the meaning of. First of all, polynomials. Well, that was a chapter in higher maths. You know, a polynomial is an expression consisting of variables such as x squared or x and constants. For example, 3x take away 7 or 4x cubed add x squared take away 8x. They are examples of polynomials. A rational function. What is a rational function? Well, that is a fraction with both the numerator and denominator as either rational numbers or polynomials. For example, 1 over x cubed would be a rational function. Or 3x squared take away 7x add 4 over x to the power of 4 plus 5x cubed would be a rational function. A proper rational function, what is that? Well, that is when the degree of the numerator must be smaller than that of the denominator. What do I mean by the degree? Well, it's the highest power of x. So, for a proper rational function, the highest power in the numerator must be smaller than that of the denominator. So here, we've got 5x plus 2 over x squared add 3x take away 1. We can take the highest power of x is just x to the power of 1. Highest power of x here is x to the power of 2. Well, x to the power of 1 is smaller than x to the power of 2, so that would be a proper rational function. An improper rational function then, what do you think that is, Mary Lou? You got it! The degree of the numerator must be equal or more than that of the denominator. For example, if we have 5x cubed add 4x plus 2 over 2x squared add x plus 7, we can see the highest power in the top is 3, highest power in the bottom is 2. The 3 is obviously bigger than the 2, so that would be an improper rational function. Or if we've got 2x squared add 5x take away 8 over 3x squared plus 9x plus 1, we can see the highest power in the top is 2, highest power in the bottom is also 2, because they are equal, x squared and x squared, we know that is an improper rational function. So, partial fractions, what is that all about? Well, if I gave you 2 over x plus 1 plus 3 over x take away 2 and I asked you to express that as a single fraction, in other words just add them together, you would end up with 5x take away 1 over x plus 1 x take away 2. And really that's a simple algebraic process that you have been doing for years. However, there will be times that we need to reverse the process, mainly to aid differentiation and integration later on. And if we split the fraction, the 5x take away 1 over x plus 2x take 1, into 2 or more simpler fractions, so in other words if we go back the way, then that is called, or is known as, expressing it in its partial fractions. And there are 4 types of partial fractions which we will come across in this chapter. First one, distinct linear factors. This is where the denominator, you can see here, it only contains linear factors such as x plus 5 times x take away 2. Or here we've got an x plus 1 and an x take away 2. They are distinct linear factors. In the next lesson we will look at repeated linear factors. This is when the denominator contains repeated factors such as x plus 3 all squared. In other words, an x plus 3 and another x plus 3. Or an x squared, an x times x. We've also got irreducible quadratic factors. This is when the denominator contains a quadratic that cannot be factorised. And we'd use b squared minus 4ac to prove this. And the last type is an improper rational function. And that requires algebraic long division first, which we'll look at in lesson 4. But let's start with lesson 1, which is distinct linear factors. So, we know that if we add these fractions together, we'll get our 5x take away 1 over x plus 1, x take away 2. If we're asked to split that into partial fractions, you can see that the denominator contains distinct linear factors. We've got the x plus 1 and we've got an x take away 2. Whenever that is the case, the partial fractions will be of the form something over x plus 1 plus something over x take away 2. And the somethings you just write as a and b. And if you add another one, you'd add in c. Another one, you add in d. For some constants, a and b. For example, if you had x take away 2 over x plus 7, x take away 3, x plus 4, you can split that into something over x plus 7, something over the x take away 3, and something over the x plus 4. And the somethings, again, you just write as a, b, and c. Let's try an example then. So example 1, express x plus 7 over x take away 2, x plus 1 in partial fractions. First thing to notice is that your denominator contains distinct linear factors. We've got an x plus 2, and we've got an x take away 2, and we've got an x plus 1. Therefore, we know that we can split that up into something over the x take away 2 plus something over the x plus 1. And again, the somethings you would just write as a and b. So we've got a over x take away 2 plus b over x plus 1. The next thing we need to do is we need to add these fractions together. So to do that, we need the same denominator. So if you notice, a over x take away 2, well, we're needing on the bottom x take away 2, x plus 1. So multiply the top and the bottom by x plus 1. So a times x plus 1 over x take away 2, x plus 1. b is already over x plus 1, but we're needing on the bottom x plus 1 and an x take away 2. So multiply the top and the bottom by x take away 2. From there, you can see we've got the same denominator, so we can add the numerators. So we've got an a times x plus 1 plus b times x take away 2. From there, how does that help us? Well, if you look at the left-hand side, you've got x plus 7 over x take away 2, x add 1. And on the right-hand side, you've got all of this over x take away 2, x plus 1. So, because they are both equal, you could cancel the denominators. Really, multiply both sides by x take away 1, x plus 1. If you cancel the denominators, you will be left with x plus 7 equals a bracket x plus 1 plus b bracket x take away 2. Now we need to work with this. So to do that, what you want to do is you want to pick different values of x, sub them in, and hopefully that'll let you work out a and b. How would we choose different values? Well, if you look at the brackets here, we've got an x plus 1 times a. If we were to make that a times 0, that would eliminate a and let us find b. And how could you make this then equal to 0? Well, if x had 1 equals 0, x would equal negative 1. So to eliminate x plus 1, and therefore eliminate a, let x equal negative 1. So let x equal negative 1, and that will give you negative 1 add 7, which is 6, equals negative 1 add 1 times a, which is 0a, which eliminates a, and negative 1 take away 2 is negative 3, so that will be take away 3b. That lets us work out the value of b. And from there, b will equal negative 2. So we know the value of b. How can we then work out the value of a? Well, we can either sub in any value of x. The only thing missing then will be a, but it's sometimes easier to eliminate b. And to do that, you want to make 0b. And to get 0b, well, you're going to have b times 0. So in other words, x take away 2 must equal 0, so x would equal 2. So to eliminate x take away 2, and therefore b, let x equal 2. So if x was equal to 2, we'd have 2 add 7, which gives us 9. 2 plus 1, which is 3, so that's 3a. 2 take away 2 is 0, so that'd be 0b. From there, we know 3a equals 9. So in other words, a equals 3. We were asked to express x plus 7 over x take away 2, x plus 1 in partial fractions. We split it up, so we wrote it as a over x take away 2 plus b over x plus 1. Now we know the values of a and b, we can sub them back in. So instead of a, we'd write down 3, so that's going to be 3 over x take away 2, plus, and b was negative 2, so it'll be plus negative 2 over x plus 1. However, if you ever get that and you're adding on the negative, what is best to do is just take the negative to the front. So that will become 3 over x take away 2, take away 2 over x plus 1. And that will be your final answer. Woo! Example 2, express 4 take away 3x over 2x squared plus 3x take away 2 in partial fractions. What do you notice first of all? Yeah, the denominator is not written in the form of x take away 2 bracket x plus 1. It's not got the distinct linear factors. So first of all, we have to write the denominator as distinct linear factors. How can we do that? What would we do? Brilliant, we can factorise the bottom. So if we factorise the denominator, the 2x squared plus 3x take away 2 will equal, and that becomes, drum roll, 2x take away 1 times x plus 2. Which means then we can say that our question will become 4 take away 3x over 2x squared plus 3x take away 2 becomes 4 take away 3x over the 2x take away 1 times the x plus 2. So we're writing the denominator as distinct linear factors. Because we've got distinct linear factors, we know we're going to then write that as a over the 2x take away 1 plus b over the x plus 2. From there, add the fractions together. So we know that a is over the 2x take away 1, but we're also needing this x plus 2. So multiply the top and the bottom by x plus 2. b is over x plus 2, but we need it to be also over the 2x take away 1. So multiply the top and the bottom by 2x take away 1. Doing that will give you the same denominator, which is what we want. Woo! High five! Which means you can then add the numerators. So we can say that that would equal a times x plus 2 plus b times 2x take away 1 over 2x take away 1x plus 2. From there, well, if you look at the left-hand side, that is over 2x take away 1x add 2. The right-hand side is over 2x take away 1x add 2. So let's cancel the denominators. And if we do that, it leaves us with 4 take away 3x equals a bracket x plus 2 plus b times 2x take away 1. From there, once again, we need to find these values of a and b. So think about eliminating the values of a and b. How can we do that? Well, to eliminate a, we'd have to have 0a. So this x plus 2 must equal 0. And if x add 2 equals 0, x would equal negative 2. So to eliminate x add 2, and therefore a, let x equal negative 2. If x equals negative 2, we'd have 4 take away 3 times negative 2. Just work that out. That gives you 10. That would equal negative 2 add 2 is 0, so that would be 0a. And negative 2 times 2 take away 1 would be negative 5, so that would be negative 5b. Point in doing that is it lets you work out b, so b works out to be negative 2. We know the value of b. How do we find the value of a? Well, again, you can sub in any value of x that you want. The only thing missing will be a, or it's sometimes best to eliminate this bracket as well. And to do that, x will equal 1/2 to give us 0 times b. If x equals 1/2, we will end up with 4 take away 3 times 1/2, which will give us 2.5 for 2.5. That will equal 1/2 add 2, which is 2.5, again 2.5a plus 0b. From there, we know we've got 0b, we've got 2.5a equals 2.5, so a is just going to be 1. We were asked in the question to express that in partial fractions. We know we had a over 2x take away 1 plus b over x plus 2. We know the values of a and b. Since a is 1, we can say that's going to be 1 over 2x take away 1. And since we know b is negative 2, we've got negative 2 over x plus 2. But once again, if you're adding and then you've got the negative here, just bring the negative to the front. So your final answer will be x 1 over 2x take away 1 take away 2 over x plus 2. And that is your answer. Example 3, express 5x plus 3 over x take away 1, x plus 2 in partial fractions. Again, what's the first thing that you notice, Max? Yeah, you've got distinct linear factors. You do indeed, which means you can start to split that up straight away. So we can say then that the 5x plus 3 over the x take 1, x plus 2 will equal, go on Max, what do you think? Good, you're going to have a over x take away 1 plus b over x plus 2. From there, we're needing the same denominators in order to add the fractions together. So a is over the x take away 1, but we need it over the x plus 2. So multiply the top and the bottom by x plus 2. b is over the x plus 2, but we also need it over x take away 1. So multiply the top and the bottom by x take away 1. From there, you can see it's the same denominator, so add the numerators. So you've got a times x plus 2 plus b times x take away 1. From there, what's the next step? What do you do, James? Yeah, you can see on the left-hand side, that's over x take away 1, x add 2. The right-hand side is over x take away 1, x add 2, so cancel the denominators. If you do that, it leaves you with 5x plus 3 equals a times x plus 2 plus b times x take away 1. So, dealing with that, we need to find the values of a and b by choosing values of x. Start off, just eliminate the value of a. To eliminate a, you need 0a, which means x plus 2 must equal 0. If x add 2 equals 0, x would equal negative 2. So if you let x equal negative 2, just write this out with x being negative 2. So 5 times negative 2 add 3 gives you negative 7. Negative 2 add 2 is 0, so you'd have 0a. And negative 2 take away 1 is negative 3, so it's negative 3b. From there then, you can work out the value of b, and b works out to be 7/3. To find the value of a, we'll try to eliminate this bracket here as well. And to do that, well, you want 0b, so x take away 1 must equal 0, so x would equal 1. So to eliminate x take away 1, let x equal 1. Work your way along, so if x was equal to 1, that'd be 5 times 1 add 3, which is going to be 8. 1 add 2 is 3, so that's 3a. And 1 take away 1 is 0, it's 0b. So we've eliminated b. It lets us find the value of a. To get a then, just divide both sides by 3, and a works out to be 8/3. Remember, our question asked us to express 5x plus 3 over x take away 1, x add 2 in partial fractions. So we split it up and we add a over plus b over, and we just worked out the values of a and b. So we can say then that we would have, replace a with 8/3, so we've got 8/3 over the x take away 1, plus, and then the value of b was 7/3, so it's 7/3 over the x plus 2. However, it looks very strange to write it like that with the fractions within the fractions, kind of blows your mind. So you need to rewrite that and really keep the 8 on the top. If you're dividing by 3, just move the 3 down here to the bottom. The same here, keep the 7 on the top. If you're dividing by 3, move the 3 down to the bottom. So a better way to write that is going to be 8/3 bracket x take away 1 plus 7/3 bracket x plus 2. And that will be your final answer for that one. Woo! Last one. Example 4. Express 2x squared take away 2x take away 6 over x plus 1 x add 2x take away 1 in partial fractions. First thing that you notice about this one, James? You got it. There are distinct linear factors for the denominator. We've got an x plus 1 and an x add 2 and an x take away 1. So we know then that we will have a over x plus 1, b over x plus 2, and because we've got a third linear factor, that will be plus c over x take away 1. From there, we need the same denominator in order to add. So if you look at a, that is over the x plus 1, but we also need it to be over x plus 2 and x take away 1. So multiply the top and the bottom of this fraction by x plus 2, x take away 1. If you do that, this is what you will end up with. Therefore, it will be over x plus 1, x plus 2, x take away 1. The b is over the x plus 2, but we also need it to be over the x plus 1 and the x take away 1. So multiply the top and the bottom of this fraction by x plus 1, x take away 1. Again, that gives us the same denominator. And c is over the x take away 1. We also need it over x plus 1, x plus 2. So we multiply the top and the bottom by x plus 1, x plus 2. And then again, you get the same denominator. Because you've got the same denominator, you can add the numerators. So we will end up with, this. That gives you something very messy, but to try and make it a bit simpler, what can you do next? Good, you cancel the denominators. The left-hand side, we're over x plus 1, x plus 2, x take away 1. The right-hand side is over x add 1, x add 2, x take away 1. So cancel the denominators out, meaning then the numerators must be equal. So we end up with this. That is what we're now dealing with, and we need to find the values of a, b, and c. So how can we do that? Well, first of all, let's think, right, well, I want to try and choose different values of x to eliminate the a, the b, and the c. What I'm going to do first of all is I'm taking this value here. I've got the x plus 2. Let's say I wanted to make that equal to 0. That would give me 0a. It would also, wherever there's an x add 2, was an x add 2 here. So that would be 0. So that would give me 0c. That would let me find the value then of b. So to eliminate this x add 2, make x equal to negative 2. So if x was equal to negative 2, if you work your way along there, 2 times negative 2 squared, take away 2 times negative 2, take away 6, gives you 6. That will equal, well, if you have negative 2 add 2, that's 0, so you're multiplying all that by 0, so it's 0a. If you make x negative 2 here, that will end up with times 3. So it's going to be b times 3, which is 3b. And if x add 2 is equal to, or x equals negative 2, x add 2 will equal 0, so you'd have 0c. Meaning then you're left with 3b equals 6. So you can write down the value of b. Again, pick another bracket to eliminate. So if we eliminate this x, take away 1, well, that will give us 0. So again, that'll wipe out the value of a, and it will also wipe out the value of b, meaning you can find the value of c. So to eliminate this x, take away 1, we'll let x equal 1, because 1 take away 1 is 0, and that's what we want. So if x equals 1, we can sub that in right the way along. So 2 times 1 squared, take away 2 times 1, take away 6, gives you negative 6. That will equal, you'd have 0 times a plus 0 times b plus, and if x was 1, 1 add 1, 1 add 2, that would give you 6 times c. Meaning then the value of c is going to be negative 1. So we've eliminated the x add 2, we've eliminated this x take away 1. The only other bit we've got is x plus 1. So to eliminate this x plus 1 would make x equal to negative 1. And if x was equal to negative 1, it would eliminate wherever there's an x plus 1, which means you'd cancel out b and c, and it will let you find the value then of a. If x equals negative 1, sub negative 1 in, work that out. 2 times negative 1 squared, take away 2 times negative 1, take away 6, gives you negative 2. That will equal negative 1 add 2 times negative 1, take away 1, times by a, gives you negative 2a. That will end up as plus 0b plus 0c, meaning you can write down the value of a. You can find that. We were asked to express that in partial fractions. We wrote it as a over x plus 1 plus b over x plus 2 plus c over x take away 1. We found the values of a, b and c. Therefore we can say that we will have a is going to be 1, so we'd have 1 over this x plus 1. B worked out to be 2, so we'd have 2 over x plus 2. And c was negative 1, so this plus will become a minus, and we'd have take away 1 over x take away 1. And that is your answer. That's quite a few examples of partial fractions, distinct linear factors. Give the questions in the workbook a shot, see how you get on. It starts with page 1. If you are needing a copy of the workbook, just send me an email, just let me know, and I'll send you a copy of the Unit 1 workbook with all the questions you'll need and all the answers as well. Just check the answers as you go along, and if you have any problems, let me know. Good luck, enjoy, bye!